Hello, this podcast is on describing motion with velocity time graphs. We're going to learn how to create and interpret velocity time graphs. First, let's take a look at creating them. And so we need a set of time and velocity data, and we need to create our velocity time graph. Now we have the velocity on the y-axis, and that's in units of meters per second, and we have time on the x-axis, and that's in units of seconds. Now notice that the x-axis is in the middle of the graph instead of at the bottom, and that's because velocity is a vector quantity, which means we can have positive or negative numbers. So we have to account for that when we make our graph. Keep in mind though that the signs positive and negative have nothing to do with the value of this velocity, but everything to do with the direction. Positive velocity is moving rightward or upward. Negative velocity is moving downward or leftward. Let's go ahead and plot these points. And so at time 0, the velocity is 0. We put our data point there. We go on to our next time at 2 seconds. And 4 seconds. And what we notice is when the velocity is 0, in other words, when the object's at rest, we have a flat line on the time axis. So unlike the position time graph, where a flat line anywhere on the graph meant the object was at rest, on a velocity time graph, it's only at rest if that flat line occurs at velocity 0. Let's move on now to 6 seconds, and at 6 seconds it's moving. And so a little strange here, what we have to do is we have to start that motion at 4 seconds, and it's moving at 2 meters per second. And so that actually started at the end of the 4th second and continued through the 6th second. So we have two data points here, and we do not connect them with a line, we just leave them blank like that. What that's saying is at the end of 4 seconds, this object instantaneously went from 0 to 2 meters per second. Now that can't physically happen. It has to take at least a little bit of time. But for beginning to learn velocity time graphs, we're just going to say this change happened instantaneously. Okay, we'll continue on. From the end of the 4th second to the end of the 10th second, the object was traveling at 2 meters per second. Notice that when the object is moving in the rightward direction, the velocity line is above the time axis in what we might call the positive region. Let's move on. Notice here at the end of the 10th second, the velocity changes direction and goes in the negative direction at 1 meter per second. So we'll go ahead and plot those points. And notice that when an object's moving leftward, we have a flat line below the time axis, or what we call the negative region. This is how you create a velocity time graph from a set of time velocity data. Let's move on now and look at interpreting velocity time graphs. Here's our velocity time graph. This is a different velocity time graph than the one we just created, and we're looking at this qualitatively. Notice we do not have a numerical scale on either the time axis or the velocity axis, other than to signify that this is 0 velocity. First thing we need to realize is that y-axis no longer represents position like it does on a position time graph. The y-axis represents velocity. So changes in the y-coordinate represent changes in the object's velocity. The x-axis represents time, just like it did in a position time graph. So if you have a change in the x-coordinate, that represents a change in time. One important thing here, you cannot determine an object's position from a velocity time graph. Nothing about this graph will tell you the location of the object relative to the origin. Let's move on and take a look at the object's direction of motion. So a rightward motion creates a line that is above the time axis. So anything in this region above the time axis, if the line's in this region, the object is moving rightward or upward. Leftward motion creates a line that is below the time axis. So in this region, we have negative motion, which is either leftward or downward. A change in direction occurs when the line crosses the time axis, as it does here. Here, we're moving rightward, and all of a sudden at this point, we change direction instantaneously and start moving leftward. We can also tell things about the object's speed from this graph. When an object's at rest, The line will be on the time axis, and we can see right here the object's at rest because the line is on the time axis. The speed is slower as the line gets closer to the time axis, and the speed is faster as the line gets further away from the time axis. So if we look at these two lines, this one indicates a slower speed than this one because this line is closer to the time axis than this line. This line is further away from the time axis. So it doesn't matter whether it's in the positive region or the negative region. The closer you are to the time axis, the slower the object's going. The other thing we can tell from a velocity time graph is an object's change in speed, also known as acceleration. And if there's no change in speed, we call that constant velocity. We're going to have a flat line. We have no change here because the object's not moving, but also up here it's a flat line. So the object is moving, but it's moving at a constant velocity. The speed isn't changing. And then of course down here it is also moving at a constant velocity, this time in the leftward direction. Speeding up creates a line that moves away from the time axis. So right here, the object is speeding up in the positive or rightward direction, but also right here, notice the line is moving away from the time axis. So here the object is speeding up in the negative or leftward direction. Finally, an object slowing down creates a line that moves towards the time axis. So right here is the one section when the object is slowing down because it's moving at a constant velocity in the rightward direction. Now it's slowing down, it comes to a stop, it changes direction and speeds up in the leftward direction. This ends our lesson on creating and interpreting velocity time graphs. Let's summarize what we've learned. First, speed is represented by the y-coordinate and time is represented by the x-coordinate. Important, position is not represented at all in a velocity time graph. The shape of the velocity time graph describes the object's motion. In terms of the direction of motion, a line above the time axis is rightward motion or upward motion. A line below the time axis is leftward or downward motion. We can determine the speed from this graph. A line on the time axis means the object is at rest and has zero velocity. The closer the line is to the time axis, the slower the object is moving. Conversely, the farther away it is from the time axis, the faster it is moving. We can also tell if and how the object's speed is changing, which is known as acceleration. A flat line means no change, in other words, constant velocity. A line moving toward the time axis means the object is slowing down, and a line moving away from the time axis means the object is speeding up. Well, this ends our podcast. I hope you found this helpful, and have a good day.